Hi, my name is dr. Ahmath. Welcome back to the course of Probability and Statistics. In this lecture, we're going to discuss about the combinations. Previously, we used to talk about the permutations, which basically means that the number of the interchanges of the items, number of the changings of the positions of the items, right? So the combinations is slightly different. So let's assume that we are given 4 different books. So previously, what we did is we found the number of ways of replacing them into a bookshelf, right? So where the position was superbly important for us. So which book is the first, which book is the second, which book is the third, and fourth. So now let's say we are going to solve another problem. Basically, hey, you would like to read any 2 books during the summer. So which 2 books, so how many different lists of the books you can create. So you would like to read 2 of them. So choose 2 of them. So you need to choose 2 of them, and I would like to know how different list of the books you can create. For example, you may choose the white one and the pink one. So it's going to be just one set. Or you may choose the yellow one and the pink one. So this is going to be another set, and so on. So how many different sets it is possible to create. So where the order doesn't matter. So it doesn't matter whether you choose the pink and the white. So they are going to be the same. So the most important one is which of the books you're choosing. So they are going to be the same. So while if you remember for this case, it is important in which order you're choosing or you're putting the books, right? So now if you just need to choose any 2 books out of 4, then it appears it is going to be calculated using so-called combinations formula. Combinations. So in this case, we need to choose 2 books out of 4. So we have 4 books, and it's going to be equal to the 4 factorials divided to the 4 minus 2 factorials multiplied to the 2 factorials. So it's going to be 1 times 2 times 3 times 4 divided to the 1 times 2. It is the 2 factorials. And 1 times 2, it is the second 2 factorials. So we can just cancel this 2. It's going to be 3 times 4, which is 12 divided to the 2. It's going to be 6. So it is possible to create 6 different set of books with the 2. Let's make a couple of more examples in order to try to understand what does it mean, this combination. So the combination, it appears, so let us write down the definition first of all. Definition. So when we say that the combination of the n and k, let's say, it is the number of set of k items chosen from n items. For example, so let's say, so this is different from the permutation. So let me write down the definition for the permutation as well. So definition for the permutation. So we have got another formula, right? P and K. So it's just the number of permutations of K items chosen from n. So let me explain you this in a very easy example. So let's say you would like to visit 3 different cities in a summer out of 12 regions. So there are 12 regions in Uzbekistan. So let's say student A wants to visit 3 cities or 3 regions. So what I want is from the student A is to give me a list of cities to which the student would like to go. So just give me a list of cities where the student wants to go. So it doesn't matter. I don't care really. So how the student is going to go to those cities. So it is just I just need the list of cities. For example, if the student A wants to go to to Samarkand and Bukhara. So just the list of cities. It doesn't matter. I don't really need the information how exactly the student wants to go to the cities. Whether he wants to go to first to Samarkand, then Bukhara, then Tashkent, or vice versa. It doesn't matter. So I just need the 3 cities out of 12. So if I say, hey, how many different lists of this kind of 3 cities list we can create, it's going to be the combination, right? So basically, so what we need to do is we need to choose 3 cities out of 12. And there are 12 cities in total. It's going to be combinations. So what we need to do is we need to divide the 12 factorials to the 12 minus 3 factorials. So it's going to be 9 factorials, and we have to additionally multiply this to the 3 factorials. So now let's say student B also wants to visit 3 cities. So I would like to know how many different routines it is possible to create. So routines means it is really important to know additionally to the list of the cities how the student B would like to go to these 3 cities. For example, the student B would like to go to the Tashkent, Samarkand, and Bukhara. So there are 6 different ways of visiting these 3 cities, right? So the student B can go to Tashkent, then Samarkand, then Bukhara, or he may decide to go to the Samarkand first, then Bukhara, then Tashkent, and so on. So for every 3 cities, there are 6 different roads. 6 roads for every 3 cities. While here, if the student A just chooses the 3 cities, there is only one list of cities, right? So this is the difference between the permutation and the combination. So in this case, if I would like to know, hey, how many different routines it is possible to make 3 cities out of 12, we need to use the permutation. So it's going to be P3 12. It's going to be 12 factorials divided to the 9 factorials only. So it's going to be just a multiplication of the 10, 11, and 12. So now if you just look to these 2 problems, you can see here like it should give you some insights about the problems. So basically here on the combinations, we just need to choose 3, and it doesn't matter in which order. While for the permutations, the order is important, right? So just putting Tashkent, Samarkand, Bukhara is going to be different than putting, for example, Samarkand, Bukhara, and Tashkent. So basically for the permutations, order is important. So this is essentially the most important difference between the permutations and the combinations. So in our next lectures, we're going to try to go through the examples and the exercises in order to try to feel the difference between these 2.